A very good day, everyone. Today we will be conducting the experiment 1, MI1, measurement of voltage and phase angle using a CRO. The objective of this experiment is to measure voltage across resistors and inductors in an AC circuit using a CRO. The second objective is to measure the phase angle and impedance in AC circuit using CRO. On this setting of the CRO, it is set at a XY mode. The waveform changes into what is known as the Lissajous figure, which is depicted in the figure 1.2. This is a figure of the Lissajous figures, which is centered on the screen of a CRO screen. The measurement of the VS, S0 and the VR are referred to the actual voltage, which can be referred to the formula here. The VL represents the inductor voltage, and the phase angle formula is under here. The Vs is the source peak-to-peak voltage, and the VR is the resistor peak-to-peak voltage. This is the source peak-to-peak voltage. This is the voltage across the x-axis. This is a sum of positive and negative axis. And this is a resistor voltage. Now let us look at what instrument and component that needed in this experiment. We need a function generator with a range of 0 to 100 Hz, and the second instrument is a resistor load of 2400 ohms and an inductor load of 7.6 Henry. Finally, we need a CRO. This is the inductor load with a 7.6 Henry. We can turn on this one and we can get this value 7.6 Henry. Another instrument we need is a resistor load. This is a resistor with a 2400 ohms. When we click this button, it will activate this 2400 ohms. We need a function generator. This is a function generator. So this function generator, as you notice, this is already in a kilohertz units. So we need at least a 50 Hertz. We will toggle this until a 50. We can adjust here a 50 Hertz, starting from 50 Hertz to 100 Hertz. So this is in the range of the Hertz is 10, and we can toggle about the amplitude to changes the voltage, which we needed is a 6 volt peak-to-peak voltage, and we can have a sine wave function. Lastly, we need a CRO. So this is a CRO machine. This is a channel 1 and a channel 2. Now let us look at the procedure of this experiment. The first step is to connect the circuit elements as shown in the circuit diagram given in the figure 1.3. This is the setup of this experiment circuit. Vs is a function generator. The voltage source voltage will be connecting to the inductor with a 7.6 Henry, and will be connecting in a series form to a 2400 ohms of resistor. Will be connected down back to the earth. So from the channel 1, the thick line will be represent the positive probe, will be connecting before at the starting of the resistor, and the thin line represent the negative probe, will be connecting to the earth. And the second, the channel 2, will the positive probe will connect in between the inductor and the resistor, and the negative probe will be connecting to the earth. So let us look at the setup. This is the inductor load. First, we will have a circuit which is connecting to the function generator. This is the function generator, and then we're connecting to here. We have a power source, and then the inductor load will have a series connection with the resistor load. So this wire will be connecting two in a series, and from here, from the output of the resistor, we have another wire connecting to the ground, which is here. The ground will be connecting over here, gathered over here. Alright, so we completed the whole complete circles. So now we're connecting the CRO channels. This is the CRO channels. For the channel 1, we have this probe. So we have to connect the positive channel 1 before the resistor. So this is the before the resistor wire and the function generator. So now this is the port of the positive. We connected here. The negative we connect to the ground. For the channel 2, we connect between the resistor and the inductor. So this is the channel 2. The channel 2, it goes into between the inductor and resistor, which is here, between the resistor and the inductor load. And the thin line, which is the negative, will connect to the ground. So this is the setup for this experiment. For the second step, switch on the function generator and set a sine wave mode. This is the function generator, and we click the power button. Alright, and then we click on the sine wave function. This is the sine wave function. Adjust the variable voltage source to the voltage source of 6 volt of peak-to-peak value. Set both CRO channels to 1 volt per division. So now we are setting this to toggle it as a, this is in kilohertz, so we toggle it to 50 hertz. We adjusting this frequency to 50 hertz and set it as a 10 hertz range. So now this is in kilohertz, so now the value is 50. And now for the CRO, we're turning on this start button, power button. So let it boots. So we set a reset, auto set. So now the system will auto set and showing 2 channel, 2 waveform will appear. Now we need to set the voltage is 1 volt per division. Now it's showing at the screen is 2 volt per division in two channel, channel 1 and channel 2. So now we are in channel 1 and we adjust this voltage per division. We adjust it to 1 volt per division. Alright, and then we need to toggle it down, adjust it down using this button, position at the center. We bring the sine wave to the center and then observe how many divisions we have. In here we need a 6 volt peak-to-peak divisions. One column, one box equal to 1 volt per division. So now we have 1, 2, 3, 4, 5, 6 volt per division. Alright, so from the top peak to the under one is a 6 volt peak to peak. For channel 2, also set to 1 volt per division. Set to 1 volt per division, and then we bring it up to the center. Alright, so the step 2 is done. Now for the step 3, go to the XY mode by pressing the horizontal menu at the CRO and select XY off from the CRO screen and press on at the side of the screen. The residual figures should be appeared. Now we are pressing the horizontal menu. Right, which will be showing the XY mode over here, and then we click on the XY mode and press on. So the residual figures is appeared. To switch off the function generator to reduce the intensity of the dot on the screen, then adjust the dot to the middle of the screen by using the up-down knob only of the CRO, switching between channel 1 and channel 2, then switch the function generator back on. So now we have to switch off the function generator and reduce the intensity. The intensity will be over here, and then we can reduce the intensity, and then by pushing the position, toggle about the position. Okay, we position it to the center by pressing the channel 1. for horizontal, channel 2 for vertical. So we place it at the center. Now it's at the center, and we certify. Alright, and then we turn on the we back on the intensity, and then we turn on again the function generator. Okay, we set the function generator the value. So now we have the Lisagio figures on the screen. What we need to do is to measure the source voltage, peak to peak source voltage, and the peak to peak resistor voltage, and the S0 voltage. So how do we gonna measure from the CRO? In order to measure the values from the Lisagio figures, press the cursor and press on at the side of the screen. This will activate the two lines on the screen, which will be used to measure the differences of the Lisagio figures. Okay, now on the screen, we click on the cursor button, and we're showing on. So we click on, will be shown to activate of two lines. So we toggle about this, and then we can measure the bottom. Okay, and we measure that at the edge of this Lisagio figures, and then we switch the toggle button to switch to the other line, and then we move it up and down to at the edge of the figures, and then the value should be shown on the here. 4.53 volts is the resistor peak to peak voltage. Now we have measured the resistor voltage. We have to measure across the V source, peak to peak voltage, and VS0. For step number 7, to change the measuring line from horizontal to vertical, select delta time on the CRO screen. Although the differences will be shown in nanosecond, but treat it as a voltage unit. So from here, the menu, click on the time, delta time, and will be activate two vertical lines. As same, toggle about this to measure for the source voltage, peak to peak source voltage at the edge, and then press the toggle. It will be measured at the edge of the Lisagio figures. Okay, this is the value, 6.15 volt. Treat it as a volt. Now we want to measure on the VS0. So VS0, we just toggle it to the x-axis where it crosses it, and then toggle to another vertical line, and then to the cross section. So this is the value, 3.57 volt. After we measure of the source peak to peak voltage, the S0 voltage, and the resistor peak to peak voltage, we jot it down over here. For the first is the 50 Hertz, and then we can calculate for the inductor peak to peak voltage and the phase angle. Alright, now we need to have the other measurement for 55 Hertz. What we need to do is just toggle the function generator to 55 Hertz. So we slowly turn this button, alright, to 55 Hertz. So repeat again to measure the source voltage, peak to peak voltage. So we toggle the button to the edge of the Lisagio figure and toggle it to another vertical line and measure the source voltage, which is 6.07, which is close to 6 volts. And then we have to measure the VS0, which is interval at the x-axis. So we adjust the vertical line to the x-axis where the intersection happens, and the value should be here. Alright, 3.88. Again, we want to have a horizontal line. We just click back on the volt When you need a vertical, click on the delta time. When you want a horizontal, is a delta volts. So again, we measure across the edge and toggle to under the horizontal line. Alright, so now the voltage is 4.35 voltage. So we have the value. We just jot it down for the 55 Hertz, and the experiment is repeated to 100 Hertz. So this is the experiment for the experiment 1. Thank you.